Meet Alan Scott, better known in the office by his nickname, the Green Lantern. He works at DC Incorporated, a financial firm. After DC shut down for 10 years, the employees have decided to return to their desk jobs. Now Alan is facing trouble in the workplace. He is constantly jealous of his two colleagues, Clark Kent, Superman, and Barry Allen, Flash. It seems, though, that Clark and Barry have hardly aged over the break period, and thus stand out as more attractive in comparison to Alan. See, Clark and Barry seem so young because of a concept in physics known as special relativity. When Albert Einstein was initially coming up with the special theory of relativity, he postulated or assumed two things: that the laws of physics are the same in all inertial frames of reference, or those that remain at a constant velocity, and that the speed of light in a vacuum is the same to an observer regardless of the movement of the object holding the source of light. These assumptions led to some rather interesting phenomena. Think of a simple clock. You may be thinking of an analog clock, like this, or even a sundial. Instead, think of a light clock. Two mirrors separated by a particular distance with light bouncing between. If the clock is not moving horizontally, then the amount of time it takes for one tick to occur is 2L over c, where L is the distance between the mirrors and c is the speed of light. However, if the clock is moving horizontally, then light is actually traveling a longer distance from the point of view of an outside observer than before. If the clock is horizontally traveling at a speed of u and t prime is the total amount of time it takes for the light to travel up and down the clock, then the distance between frames from the light at the bottom mirror to the top mirror is given by u times t prime over 2. Then, by the Pythagorean theorem, the distance traveled by the light from an outsider's perspective is the following expression, which means the following. Rearranging and substituting gives t prime equals t over the square root of 1 minus u squared over c squared. From what we know today, u will always be less than c, so this yields a value of t prime that is greater than t. As such, the outsider who sees the horizontal movement will view that more time has passed than the person observing alongside the clock's movement. Looking back at DC Incorporated, Clark and Barry are known for traveling at high speeds. Say they spend their gap years traveling at 0.99 times the speed of light for a total of 8 years in the eyes of outside observers. This means that t prime equals 8 years and u equals 0.99 times c. Plugging into the time dilation equation yields t equals 1.13 years. So Superman and Flash have only aged for a little over 1 year, while their fellow office mates have aged 8 years in that time. Using this information, the Green Lantern now knows that he can resolve his issue by putting on his special ring every once in a while and going on an easy run at near the speed of light. Finally, now we know why Superman and Flash are still so young after being in their movie franchises for so long.